All right, so welcome back. Welcome back to the channel. So in this video, as you have seen in the title and title and the thumbnail, right? So we are going to discuss about Palm 2, what Palm 2 actually is, right? So it's a model released by Google, right? You might have heard about it also, Palm 2. And currently, we couldn't actually use the API. I don't think they have also have it, and I don't think there's a model on Hugging Face also. We'll see that, right? So we're going to first cover the paper, right? What the changes they have done. So essentially they have just like scaled the model, right? They have just scaled the language models into like huge models, and they have made like slight changes. I thought maybe it will be nice to share with you, and in the future we are going to work a lot with LangChain and these models. So we're going to do a lot of work in the future. Uh, I think I'm going to put a bunch of videos, and also I'm working on a project currently for like professional reasons. I'll share that also. So yeah, so this paper, Palm Scaling Language Modeling with Pathways. uh, we'll see what the model actually does, like what the changes are in this model. So I'll just, yeah, maybe yeah. So you could read the paper, like this is like a huge paper with like 87 pages. I don't know what they have done, but I think they have like uh I think they have like introduced the main things, the main changes, the main data sets and all that, the main model architecture differences in like the first part, like first part, very small part. And they have like performed like bunch of experimentations on like different tasks of NLP, like memorization. Is the model able to memorize everything? And they have run like multiple experiments, I believe, and also compared it with different other models that have been in the existence currently. So there has been like a lot of hype in language modeling. Like all the companies are like looking for building language models. So there has been quite improvement and for development in language modeling, and I could definitely say that this is one of the work, and this is actually a very good model they have built. So let's go to the paper. Let's see what it has to say. So we have a bunch of introduction. So GPT, they also talk about GPT-3, right? So so there have been a number of large auto regression models have been developed. Yes. And then so in this work, we continue the scaling line of language models. So there's essentially scale the language model and train a 550 billion parameter densely activated auto-regressive transformer on 780 billion tokens of high quality text. So essentially, we are going to again build an auto-regressive transformer. That means taking the previous words and predicting the next word, and densely activated. So we're gonna have a bunch of dense, like very high computational model with like many neurons and all that, or many attention blocks, right? And train a 550 billion parameters. So we're like 550 billion parameters and 780 billion tokens, right? So we're gonna have like 780 billion words, um, right? So this was achieved through the use of pathways, a new ML system which enables highly efficient training of very large neural networks across thousands of accelerated chips, including those spanning multiple tensor processing units, TPUs. This new model called Pathways Language Model achieves, so Pathway Language Model, PALM, achieves state-of-the-art few shot results across hundreds of natural language, code, and mathematical reasoning tasks. We achieve breakthrough performance on a number of these tasks. So essentially, the main thing that they have done is they have created a pathway language model, which is with like computationally efficient to train. So we'll see what that is. So efficient scaling, we demonstrate the first large scale use of pathways, a new MS system. Okay, so we have done that, right? So yeah, it has also like work very well in many like evaluation based on both in uh like efficiency and also the performance, I believe. So you can also see that the model can explain a joke and also get logical inference. For example, I'd say that, did you see that Google just hired an eloquent whale for the TPU team? It showed them how to communicate. There is a joke Even I don't get it, but the model is able to make like explain the joke in like very good terms. I mean, definitely GPT could do that, but uh, I mean, think about it. Like, they don't have to perform better. Like, they're just one step ahead. They're getting one step ahead. So taking the previous model, taking account the previous models, just taking one step at a time. So like with this model, we can achieve like better efficiency and all that. For like, um, the model can run faster, and we may use the power of GPUs, which will cover. And also, the model can do logical inference. So let's say we have like, let's say text. So Shelly is for Virginia, but is visiting the city with the famous market where they throw the fish. Going home next Tuesday. Question: is it likely that Shelly will be near the Pacific Ocean this weekend? And the model is able to, say like the city's the famous market is in Seattle, Washington. Seattle is on the Pacific Ocean. So of course, Shelly is visiting Pacific Ocean, which is actually pretty, I think, pretty logical and pretty good, right? If you think about it, maybe from the name also, the model is able to tell that maybe it's from Washington also, and it's actually a very good sign. The capabilities of language models are getting like way better and better as we go on, and as you can see, uh, uh, so yeah, the model is able to achieve breakthrough performance, like, sorry, multiple tasks, language understanding, and release reasoning tasks, chain of thought prompting. I think like carrying like context around like bunch of uh, I think chats, like just like human. And also, discontinuous improvement. To better understand the scaling behavior, we present results at three different parameter scales. Okay, so we are like, they train like not only one model but different models with like different number of parameters and different amount of scaling. So they have like scaled one like with like less parameters and one with higher amount of parameters, right? um and yeah, as you can see, the model is able to understand very well. And also we have like multilingual understanding. Let's say like 20%, 22% of non-English data. So based consisting on different other languages also, which is actually pretty good. And also Llama is also trained on that also. Right. It also evaluated model performance for distribution bias and toxicity, which is result in several insights. Firstly, for gender and occupational bias, we found that accuracy of the we know gender covariance task improves the model with model scale, and PAM 550 billion sets a new state of the art result in one shot and few shot settings. Secondly, co-occurrence analysis performed on race, religion, as gender from continuation demonstrates the potential of the model to fastly affirm stereotypes, for instance, associating Muslims with terrorism, extremism, and violence. This behavior was consistent across model skills. Finally, toxic analysis and prompt continuation demonstrates a slightly overall toxicity level for the 62 and final parameter of the 8 model. However, the toxicity of the model generated continuation correlates with highly with the toxicity of the prompting text. So yeah, so the prompt that will be case of yeah. So the basically this is all like not very important stuff. I mean like like they are selling, they are they are making sure that there is no like toxicity with for like different religions or different races and different genders. But and yeah, like so the prompt actually influences a lot. So based on the so the toxicity as I say in the output, we actually based on the prompt. So you know they're like working they're working they're doing some feature work. uh yeah, so they are like, I think they are solving this problem, they're just doing some feature work, which is actually pretty good. And now let's get to the I think the architecture part, the model architecture, the changes that I've done. So PALM is a standard transformer architecture. Of course, every language model now uses a transformer. So if you are not if you have not known about transformer, if you don't have any idea of transformer, I have video series. I have video series on transformer. And even if you don't have idea of deep learning, right? If you're just watching this video just for fun, well, okay, that is cool. Like you could watch this video, but I would highly recommend you to actually like watch my videos from first, or even like maybe read some papers or watch some videos online or take a course, because deep learning is pretty interesting. Like if you are a maybe a student or someone, uh, definitely take a course, and deep learning is pretty exciting today. And please join me. We're going to go through this field, and we're going to learn something very good. So please go through my transformer series if you want to, and if you are comfortable with it. If you are like, if you have new to deep learning also, well, you are welcome to join me. And I'll also probably publish YouTube deep learning videos from like the beginning. So I'm getting out of context here, but so let's get back to PALM, pathway language model. So again, they have used Swigglue activation function, right? Like I think also in like Llama 2, they have used this model Swigglue. So essentially, it is a combination of Swish and so we'll essentially like uh, a separate activation function rather than ReLU. I think I'll probably make a separate video for that, because this activation function is I think probably pretty good, because both Google and Facebook uses it for one of their best models. Right, I'll probably make a video for Swigglue activation function maybe in the future. But just keep in mind that they perform better than ReLU, maybe especially for language tasks. Um, so maybe using Swigglue does make sense. And also they have something called parallel layers. I wouldn't say, yeah, maybe parallel layers, but let me tell you something. So the GPUs in modern era, so there has been like tremendous increase in the power of GPU, NVIDIA 1490 and all that, RTX 1490 and all that. So there has been multiple amount of GPUs that have been coming up. So these GPUs are better and efficient at performing tasks, and they're pretty fast, right? So number one, they are pretty fast. GPUs are pretty fast. Number two, they have much higher effective like calculating. They can do like fast calculations. So in the normal transformer, so this is the first normal transformer architecture, right? So we'll have like attention mechanism will perform the attention. So we'll just take an X, we'll perform the layer normalization, we'll pass that through attention, and after that we'll add X to it, and after that we'll perform layer normalization. On that we'll have like MLP layer, multi-layer perceptron, and then we're going to add the residual X, this residual X. So the point I want to state here, right? The point I want to state here is that every function that has to take place. So there are like a lot of functions here. We have layer normalization, attention, layer normalization, MLP, right? So we have like multiple layers or multiple functions. So every function has to take one by one. So first we'll take an X, we'll pass that through layer normalization. So we have to make sure the model performs this function first, and then again the model perform this function, and then add this addition function, and after that layer normalization function, and on that MLP function. It's which is pretty sequential. So every task goes on sequence by sequence. So for taking next, we'll perform layer normalization, attention operations, and layer pretty in a sequential manner. We'll perform everything in a sequential manner, and after that we'll perform we'll perform addition, and then we'll perform layer normalization one by one. And by performing this this algorithm, so by using this algorithm, we cannot use the power of GPUs, right? GPUs are better at parallel computation. They can compute everything parallelly. So computing, like performing two functions parallelly, they are good at that. So we couldn't actually use it. So therefore we'll have a parallel formulation, which is actually pretty simple. So rather than just like having X plus attention on like inside this layer normalization function, we'll perform this layer normalization on X, and also we'll taking attention and perform layer normalization on X. So essentially, rather than just performing everything sequentially, first perform this, then this on all both of this and all that. So we're performing everything individually, right? So we'll be performing everything individually. So we'll performing attention individually and layer normalization individually. And there is not a huge amount of disparity in the performance or the calculation. But we have achieved parallel formulation. Through this, the GPU can train faster because GPU is better at parallel computation. It should compute both these functions at the same time, right? And that is actually pretty good. And the other thing is we use something called multi-query attention. So the standard transformer formulation uses k attention heads, where the input factor for each time set is linearly projected into query, key, and value tensors of shape kh, where h is attention head size. Here k key or value projections are shared for each head. That is k, but query is still projected to shape kh. We found that the neural that this has neural model quantity and training speed, but the results in a sorry for that. Right, and then yeah, so essentially in multi query attention, we'll just like share the key and value weights. So we'll have like bunch of weights in attention, right? So we'll essentially share these weights, uh and we're going to, so as you can see, um so but the results in because standard multi-attention has low efficiency on accelerator hardware during auto recursive decoding, because the key slash value tensors are not shared between examples and only a single token is decoded at a time. So therefore that is multi-query attention. And then again we are going to use rope embeddings. So again similarities can be seen in llama 2 also. The same rope embeddings are actually used. And then so essentially rope embeddings means like relative embeddings. Just think of that. So we're going to have like relative embeddings with each word. So while performing attention between two words, we're going to calculate the relative embeddings between those words, the positional difference between those words, rather than just like constant positional embedding for each word. So and then after that, we're also going to use shared input output embeddings. So when you're performing sequence to sequence tasks, question answering model maybe, so we're going to use the same embedding matrices or the same embedding model for both input and output, for both encoding the input and encoding the output. We're going to do that. And then we are not going to use any biases. We are only going to use weights. I think they have observed that this resulted in increased training stability, and also they have like changed I think the training data. Right, so the worker is completely lossless. So they have like reduced the loss of data. So they have tried their best to do that. And then the bunch of hyperparameters, you could go to that, number of layers and all that. And then yeah, so that is I think the main part of the paper. And but they're like bunch of experiments and all that. Definitely try to read it if you're interested, and also like references and all that. So if you are interested, go to the paper. I think I'm going to end the video here. Actually, they have I found this website, and they have created this website called MakerSuit. I think this will have through this you could access the API key to use Palm 2, but it is still not yet I think created maybe, or maybe it is a wait list. So I think maybe it will take some time to actually release Palm 2 for like using general use maybe. So that is for this today's video. Thank you for watching. I'll see you in the next one. So bye.